Welcome to our webcast. This is a webcast sponsored by IBM and the International Informix User Group. I'm Lester Knutson, a board member of the International Informix User Group, and really looking forward to this. Informix 1410xC6 has just come out, and this is the first of two webcasts about new features. It's a deep dive into it. The next webcast, in case you signed up for it, had to be moved to July 13th. So it's been rescheduled. If you signed up for it, the new date is July 13th. And with that, please keep your lines on mute during the webcast. If you have questions, find the chat button in WebEx. I know in different OSs it shows up in different places, but find the chat button, put your question in the chat, and send it to everybody. Don't just send it to one person like me, because you want Carlton to see it, and it's really good if everybody sees what the questions are. So ask your questions to everybody. Carlton will pause after various sections to answer questions. And with that, Carlton, you want to take it away? Thank you. One other reminder, I'm really excited about this. We're having a IIUG conference this year, and it's going to be October 5th to 7th. It's a virtual conference. There'll be 3 half days of hour-long technical sessions, and a key new part of it is the IBM 14 exam. There's a new IBM certification exam that if you attend the conference, part of your registration will cover the exam fee. So watch out for more information coming soon. Thank you, Carlton. I think the rest is yours.
Thank you, everybody, for joining today. A little advertisement for the second session. I know some of you may not be all that enthused about IIHQ, but there are some nice features in there that JC mentioned. But the backup from an RS secondary is a very, very, very interesting feature. And that actually takes up the bulk of the presentation. There's some nuances to that I think are kind of exciting and in some cases fun to know about, but also just things you need to know. So make time for that. It'll probably be of value to you. Today, I'm going to talk about kernel features, changes in enterprise replication, and just do an overview of some of the new SQL features. JC last week did an amazing job with an overview of these, and as he promised, we're going to get down and dirty into syntax and screen captures and everything else. So let's just dive right into it. First thing you need to know about is moving to XC6 is not as straightforward as moving to earlier releases of Informix. Back in 1210xC5, we introduced the concept of rolling upgrades in the HA cluster functionality, where you could move from one fixed pack to another, let's say from XC5 to XC6 or XC6 to XC7, or you could move from a fixed pack to an interim, or from an interim to the next logical fixed pack, and so forth. And we said you can take your cluster, you can take a node down, migrate it to the new version of the OS or of the engine, turn it back on, and just continue with this mixed version cluster. We told you that there were 2 controls inside the rolling upgrade functionality that would prevent you from doing what we called out of bounds upgrades. For example, trying to jump from XC4 to XC7, that just wasn't allowed. But we also said that there would be cases where we would prevent you from doing an in-place upgrade, even if it should be allowed. For example, in this case, from 1410xC5 to XC6. We said that some of those root causes could be either disk infrastructure changes, similar to what we did in version 10, if we were going to be playing around with the logical log structures, or if there were going to be major systemic changes to some of the system tables. And that is occurring in 1410xC6. We are making some fairly significant systemic changes to the sysmaster tables. And as a result, you will not be able to do a rolling upgrade of your HA clusters. You will need to take an outage, if you have them, to migrate. And that migration process is similar to what we used to have prior to rolling upgrades. You will need to turn off the entire cluster, so the primary and all secondaries. You will load the XC6 binary on each node. You'll update the onconfig files if you want to take advantage of some of the new configuration parameters that are out there. You'll turn on the primary, you'll let it convert, leave it online, and then turn on each secondary one at a time, allow it to convert, and then to connect into the primary and rejoin the cluster. If you have any shared disk secondaries, we strongly recommend you leave those till the very end of the process and then migrate those. So if you're using an HA cluster, there is an outage required. If you're using ER clusters, you will see a little bit later on when I get into the ER section that there is some specific conversion that needs to occur within ER as well. So just be aware of that. So let's look at what some of the new kernel features are. And this is a basic agenda of what is in here. Some of these kernel features may probably fit better in an SQL section, but this is where they drop, so this is where they're going to stay. And by the way, a few of these screenshots come courtesy of JC. I don't have a pSeries machine with 3 terabytes of memory at my disposal, so when we talk about large-scale addressability in the pSeries section, all of those screenshots came from JC, and I appreciate all his work. So on the IBM P8 and P9 series of hardware, if you were running AIX or if you are running AIX, we have experienced, let's just call it some severe challenges in trying to get Informix to work on that platform. As the workload increased and increased, performance got steadily worse. And we struggled for a while to figure out what the problem was. We now have identified it, and we have coded the fix in XC6. Now, historically, Informix has always used shared memory address blocks that began on a 256 megabyte address boundary. And that works for all OSs, all ports. It has been universal across the product for, I think, since the beginning of time, basically. What we have found, though, is that on P9 hardware and using AIX, that AIX uses a different memory address scheme. It has 12 slots, and those slots align on a 1 terabyte memory address boundary rather than the 256 memory address boundary that we've been using. And as a result, as we added more shared memory structures, resident portion, virtual portions, and so forth, we were getting significant memory address misses when we tried to find a particular buffer or component of shared memory, and that's why performance on AIX was tanking. So for AIX ports and AIX ports only, there is a new configuration parameter called AIX_LSA. There are 3 possible values. I'll talk about the first 2 now, and then the third one a little bit later on. The first one is off, which says you want to use the legacy 256 memory address boundary, and you're really comfortable with AIX performance or Informix performance on AIX that just stinks. If you do, more power to you. But what we strongly recommend is that you leave it on the default, which is on. And what we will do is internally, we will realign our memory address structures to the AIX 1 terabyte memory address. And so here you can see that the resident portion of shared memory is on 1 address. First virtual portion is using the next of the 12 slots on its terabyte memory. We've got some buffer pools and so forth. So that's how it works. Now, this does not mean that your allocations of shared memory have to be 1 terabyte in size. You can still configure your resident portion for whatever size you need, your virtual portions for whatever size you need. It's just that each one will fall on a 1 terabyte boundary address. What happens if a particular allocation of shared memory exceeds 1 terabyte? That's just fine. As you can see in this slide, we have a virtual portion that's 1.7 terabytes in size. What it will do is take its memory address boundary, and since it flows over into the next memory address boundary, you can see that the first buffer pool is taking slot number 4 rather than slot number 3. So again, you can size your shared memory structures as large or as small as you need. However, remember, you only have 12, and this is where it gets kind of interesting. Once you hit that 13th segment, you will see performance start to decrease. Now, it won't be significant on 13, but you will see it. And as you add more, the performance will continue to degrade. So what we did is we borrowed some technology from Solaris, which allows us to combine the resident and first virtual portion of shared memory to use the same shared memory segment address. If you set the AIX_LSA to 2, that's what will happen. And as you can see in this screenshot, the resident portion of shared memory is using slot 1. The virtual portion is also using slot 1. But since it is 1.7 terabytes in size, it's rolling over into the second address slot. And so the first buffer pool allocation is using slot 3 now, as opposed to slot 4 earlier. That is pSeries shared memory addressing fix. The next feature has to do with query runtimes and the ability to disable queries if they've been running for a period of time. If you do an -G, either SES or SQL, you will now get information on the runtime for a query. As you can see in this example, I have a fairly simple query. I'm just taking data from systables, syscolumns, and sysindexes. It's not the most efficient query. There's no predicate to it. So we're basically doing a series of sequential scans and joins and so forth. I'm doing an -G SQL on this session. You can see that it's been running for 14 seconds, then 32 seconds, and then for 50 seconds. And then I eventually interrupted the query. As long as the query is running, you will see this clock time elapsed value. Once the query does complete, however, that clock time value goes away. So it's not as though you can go in and look at what the runtime was for a previous SQL statement. If you want to do that, then you need to do query capture and some of the auditing features and so forth that are in Informix. This is where it gets really fun and really exciting. We have always asked for ways to tame our customers. You know, they'll come in and they don't know anything about writing an SQL, and they think it's just really cool to write a series of left outer joins across 7 1 billion row tables. And of course, the performance just tanks. And everybody whines and complains, how come our instance is running slow? Well, in 1410xC6, we now introduce a session level environment variable where you can specify how long a query can run before it's automatically interrupted. You can set this value between 0, which means it runs until completion, or to 10,000 seconds. And by the way, this environment variable is case sensitive. So if you try and use it in lowercase, it won't work. But anyway, this variable only affects queries. It does not affect DML operations. So if you're doing some batch updates or batch loads or something like that, it will not interrupt your batch. Now, if you're doing a series of batch queries, where you're doing a series of very, very long queries, then they might be interrupted. But this variable needs to be set for each user session. It's not something that you can set at an instance level. If the query is interrupted, there is no message output at this moment in time into the message path. It is something that JC is working on, and so I would expect to see that perhaps in the next fix pack. But the query will just be interrupted and off it goes. The other thing you need to know is the interruption. If you configure this for 10 seconds, the interruption will not execute at exactly 10 seconds. As we're going through the query processing roadmap, if you will, there are internal breakpoints, and it's at those breakpoints where we will check the query runtime with the query timeout value. And if the time has been exceeded, then we will interrupt the query at that particular moment in time. So how do you set it? Like I said, it's done at a session level, so you can export it into the session environment. In this case, I'm setting it to 20. So you can set it, and then you can go into DB Access or whatever your application is and go ahead and execute your query. Or within the application itself, you can use the set environment query timeout value and then run your queries, and off it will go. And this is what it looks like. So I've gone ahead and set this environment variable for 20 seconds, and I have restarted the query. And you can see that I'm checking the query, and so far it's been running for 15 seconds. I check it again, it's been running for 18 seconds. I wait a few more seconds, check it again, and the statement has been interrupted. That's how it works. At a client side, they will get a -213 error that says that the statement has been interrupted. It appears as though we've done a Command-C on the query. So in your whenever error functionality, you will probably want to trap this error number and code around that. What is interesting about this feature is in DB Access, if you're running queries in the interactive mode, as you saw me earlier, the timeout value works. If you use DB Access in menu mode, where you say query new, type it in, escape, run, the query timeout value does not work. And we're not exactly sure why. This is something I found and brought up with development. It's not something that they tested. So again, you can see I'm doing a select star from customer. I'm waiting on the first query result on my screen, and you can see that the query continues running well past what the timeout value should be. Now, I don't know if this is because in menu mode, DB Access is pre-caching data, or it's not sending an interrupt back to the query, so the breakpoints are triggered. Not really sure yet, but just be aware of that particular nuance. Okay, last DML in a table. This is something that is an enhancement of functionality we introduced in XE2, where you were able to look and see whether or not a particular index was being used. We now are giving you the ability to see if a particular table has been updated recently. So here in this example, I'm creating a small table. It's got 3 different fragments in it. I insert some data such that it falls into the first 2 fragments, leaving the remainder fragment empty. If I do an on check now, there is a last DML time that shows for fragment 1 and fragment 2, it was updated at a particular moment in time, but fragment 3 has not been updated as yet. If I go in and add another row, in this particular case, the data qualifiers fall such that it goes into fragment 1, and again, I grep for the update time, you can see that fragment 1, it has a new last DML time, but fragment 3 is still empty. If you add an index to the table, its fragment and access time will also be included. So this is an interesting feature as well. We've always had the ability to create DB spaces of differing page sizes, and it was always a multiple of the default page size, so 2, 4, 6, 8, 12, 16. I would go around and teach people that there were reasons why you would want to create DB spaces of different page size. The most important was storage efficiency. If you had a row that was 3K in size and you put it on a 2K page size, you'd end up using 2 pages and wasting half of the second page because we don't ever backfill the remainder pages. Whereas if you created a DB space that was 6K in size, you could fit 2 rows on a page without wasting any disk space. That's always been a nice feature. I don't know how many people are actually using it, but it is nice to have. Now, you have also been able to create temporary DB spaces of different page sizes as well. For example, this is a screenshot from XE3, where I create a series of temp DB spaces using a 4, 12, and 16K page size. And you can see that I can create them, the files are there on disk, but you couldn't actually register them in the instance as a temp DB space. So here you can see that there is a default temp DB space called workspace. I've created those temporary DB spaces. I want to configure the instance so that it will use these 4, 12, and 16K DB spaces. And the instance would just say, nope, I will only use the default page size spaces. We strongly recommended that you leave all your temp DB spaces at the default size. Some of it was for recovery purposes. When we are doing logical recovery, sometimes we have to write out logical log records, and since those logical log records are always in default page size, they had to be written into a temp DB space that was at default page size. In XE6 now, you can configure temp DB spaces of differing sizes and include them in as valid temp DB spaces for the instance to use. Now, we strongly recommend that you leave at least 1 temp DB space at the default page size so that logical recovery will succeed. So here's an example. I have my instance. I'm starting with my default 2K page size here. I add a 412 and 16K DB space. You can see that they're created, they actually exist. Now I add them to my instance, and sure enough, now I have a default 4, 12, and 16K temp DB spaces that the instance can use. Woohoo, great, right? Well, not exactly. These larger page size DB spaces will be used if you explicitly call them out in your create temp table statement. So if you know you're dealing with a row size that is 12K, and you want to put that in a temp DB space that is 12K in size, you are going to have to explicitly call that when you create the temp table. Without an explicit placement clause, or for implicit tables that the instance will generate automatically, it will use the temp DB space that is least full, regardless of what the row length is. So the instance isn't going to say, okay, I'm doing this outer join here. I need to create a temp table. Let's see, the row size is 16K, so I will use the 16K DB space. It will just grab whichever one is least busy and use it, even if that means fracturing the row across multiple pages. But at least now you can use them efficiently. Parallel smart large object space cleaning, or as I like to refer to them, slob space cleaning. The garbage collection process that goes into cleaning up slob spaces only occurs when the instance is started. Prior to XC6, it was a serialized operation. Now, normally there isn't a whole lot of garbage collection that needs to go on in slob spaces. But if you're doing an enormous amount of slob updates and the instance crashes on you, then it could take some time for these slob spaces to get cleaned up. With XC6 now, we introduced the SB space cleaners parameter that controls the number of parallelized threads that will be forked off for garbage collection on startup. The range is between 1 to just over 2,000. If you set it to a number smaller than the actual number of smart large object spaces you have, we will work on that number in parallel, and when one slob space finishes, we'll grab the next one in the queue and work on that. If you set it to a value larger than the number of slob spaces you have, we're only going to invoke the number of threads we need to clean them up. By the way, this parameter is not dynamically tunable, so if you need to make changes to it, it will require a system restart. Whether or not a table was explicitly created with row IDs, the IFX row ID pseudo column has always existed, and you could query it. Now, the format of this row ID is a varchar that contains two values. The first was the fragment ID, and the second was the row ID. And you could use these as a predicate, and you could actually scan a table for a particular row ID. The problem was it was horrifically slow. So this is a query that's being done on I think it was a 4 million row table, and I was looking for a row ID basically in the middle of the table. And as you can see, it took 2.048 seconds for this query to complete. Now it did complete, I was able to get a value, but it was just horrifically slow. With XC6, if you're using an equality predicate where you're looking for a specific row ID, you will now get near index-like performance on that query. We will no longer do a sequential scan. We can find it much, much quicker. As you can see here, again, the exact same query on XC6, it took just over half a second to return the row. Now, if you are using a range of values, if you're using a matches statement or something along those lines, you will get a sequential scan. So you have to be very careful in how you write these queries in order to take advantage of the performance increase. When a table is created with round-robin fragmentation, rows are evenly distributed between all of the fragments. Now, assuming that there are no deletes in the table, the fragments will grow in size uniformly over time. For example, I created this small table. It has 2 fragments in it, and I loaded it up with 5,000 rows, and you can see there's 2,500 rows in each fragment. If I add an additional fragment to the table, it receives rows one at a time, just like all the other fragments. I added this third fragment. I inserted 3 rows into the table, and you can see that there's 2,501 in fragment 1 and 2, and 1 row in fragment number 3. And that's the way round-robin fragmentation has always worked. In XC6, we have added auto-locate-like functionality to round-robin fragmented tables. And so what's going to happen is when new rows are inserted into these round-robin tables, they are going to automatically be put in the fragment with the least number of rows. And this process will continue until the fragments are what we refer to as reasonably balanced. Then any new inserts will be distributed across all the fragments again. Well, what does reasonably balanced mean? We're going to check the row count about every 100 rows. Then if the tables are within 100 rows of each other, then we'll roll over and start using the next fragment. So what you could see in your environment is fragment 1 and 2 with 300 rows, and fragment 3 with a value somewhere between 200 and 300 rows. Once it hits 300 rows, then we'll start working on fragment 1, fragment 2, fragment 3 in 100-row groups. So here's how the functionality works. I have my 2 tables out there, or my 2 fragment table out there. I add another fragment. I've turned on this functionality, and I insert 70 new rows. And as you can see, those rows are all inserted in the 3rd fragment. And this will continue until I get 2,500 rows, and then we'll start distributing between all the fragments again. This functionality, the parameter which controls this, is not documented. So don't tell anybody that I told you. The parameter is called legacy_round-robin, and it takes a Boolean value. The default is 0, meaning that we want to disable the legacy process of 1 to 1 to 1 to 1, or you could set it to true or on, at which point it will do the 1 to 1 to 1. So that's the parameter. Now, what is important is if you have turned on auto-locate within the instance, it provides far more functionality and control over where rows go in tables. So if you have that turned on, disable this hidden round-robin flag because you won't need it. We will take care of it for you. So with XC6, Informix now supports TLS 1.3 for network connections with all of its enhancements and security and everything else. And we are positioning TLS as the successor for SSL. What you need to know, though, is that the default configuration within the instance is still TLS 1.2. You can use the TLS_version configuration parameter to specify which version you want to use. But there is a caveat to this functionality. If you're using the IBM GS kit, TLS 1.3 does not support FIPS mode yet. FIPS stands for the Federal Information Processing Standard. So if you're using GS kit and you specify FIPS, the instance will default to 1.2. As a result, we strongly recommend you disable FIPS if you're going to use GS kit. And there is this ISI GS kit FIPS mode equals off environment parameter that you can set, which will disable FIPS for GS kit. Now be aware that ODBC and other client connectivities are not affected by this FIPS TLS 1.3 issue. It's just GS kit clients. That's the end of the kernel section. Are there any questions that I need to be aware of? Does the AIX and memory address also affect virtualized LPARs? The answer to that is yes. If you're running an LPAR on AIX on P9, you're going to be affected by it. How does the app know that it's a -213 error? You're going to get an error back. The query will abort, and just like any other aborted query, you can check the SQLCA code to see what was returned. Jack Parker is asking how frequent are these checkpoints. I'm not sure what he means. Oh, the timeout checkpoints. The value for the checkpoint or the query interrupt is at a 1-second boundary. So you can set it, as I said, between 1 and 10,000 seconds. Where within that time frame are we checking? Like I said, it all depends on where the breakpoints is in the query processing. It's usually fairly fast. So if you set it at 10 seconds, it's going to occur somewhere right around 10 seconds. It might be 11, it might be 11 and a half. I can't really say exactly because I don't know where a particular query might be in the processing roadmap and when these breakpoints occur. But it's not as though if you set it for 10 seconds, it's going to run for 2 hours. We'll definitely hit a checkpoint or a breakpoint before then interrupt. So let's look at SQL features. These are the 3 or 4 things that I'll be discussing here. And the first one is an Achilles heel of mine. I have almost no experience with auditing. Don't ask me any difficult questions on this because I'll have to say I don't know and get the answer to you. What's happening in XC6 is we are enabling on-log output to be written to the syslog system level auditing feature. And this is being driven primarily by customers in the financial industry who have to have a unified single audit functionality. This functionality is only available on the Unix platforms, so the AAXs, the Unix, the Linuxes, and so forth. It is not available on Windows. And implementation of this will require coordination with your OS administrators to configure the syslog daemon and other interfaces that require root level permissions if you don't have root. And obviously there is no single cookbook for this because each OS handles syslog functionality different. The daemons are named differently and so forth. With this functionality, we have deprecated the audit mode on config parameter. So be aware of that. This takes effect immediately across all of the Unix platforms. So the on-audit utility has some new or modified flags. Most of the new flags are using a capitalized letter, and they all require some sort of a parameter value. Some of the heritage flags using lowercase have been deprecated, and they've been replaced with these uppercase options. Some of the new flags are a help message flag, which will show you what your particular options are. There's a new queue option that suppresses the banner line. So you don't need to get, this is Informix 1410xC6 on every audit record. That option to disable it has been introduced, as well as the ability to output in single space rather than double space output. We give you the ability to determine whether or not you want to audit the database security officer actions and whether or not to disable auditing to syslog in general. There is now a new facility flag, which is some functionality that's involved in syslog. Like I said, I don't really understand how this works, where you can specify some, I guess they're called message group identifiers. So there's log user and log local 0 all the way up to log local 7, which you can use to identify where these messages are coming from, as well as an identifier for what the instance name or some other identifier that you can explicitly set so we know where the messages are coming from. There are some other options here that you can read through in the documentation. Like I said, this is an Achilles heel for me. I don't have a significant amount of experience with it. Send me your questions via email and I will do my best to get them answered for you. We now also allow the on-show audit utility to parse and use the output that's written into syslog. We will need to know, though, where that syslog file is. So there's a new -J option where you'll tell us where to find the file. Be aware, however, the syslog function does add information to the beginning of its audit line that Informix does not. Typically, this data isn't pipe delimited, so it shouldn't interfere with how on-show audit works, but your mileage may vary. Your OS may do some things that other OSs don't. The other thing to be aware of is the syslog timestamp or the time zone that syslog uses may be different than how the instance is configured. So you may have some difficulties reconciling the timestamp from the syslog output with the timestamp within the instance. So just be aware that that could exist. Temp DB space utilization. The query to figure out how much temp space is being used by a query or by all queries has been available for a while, but it was a rather convoluted SQL statement. What we have done is we have taken that statement and codified it into a view. So there is now a syssession temp space usage view that you can query. And you can either grab all the temp tables, which will include all of the explicit and implicit temp tables, or if you know what the session ID is or what the temp table name is, you can use that as a predicate and pull out just the temp tables associated with that session or that particular temp table. This is something that's nice, ease of use enhancement. You may use it significantly, you may not, but it's there for you to use if you want it. So customers have always wondered, are these Java user-defined routines or these SQL UDRs being used? And until now, the only process you had to figure out was to drop the UDR and see what breaks, which is not really the best option. The sysmaster, sysprc, and BSE tables now contain a timestamp when the UDR was last used. It timestamps both internal system UDRs as well as end-user created UDRs. So you can now query these tables with the specific UDR you're looking for, and you can see the timestamp there. If it hasn't been accessed in a while, you can get rid of the UDR. So customers have been using dbinfo function to interrogate the instance using partnum as a parameter. And for the most part, querying using the part number has worked, but there were cases when the function would, quote, fail with -727 errors. In truth, the function wasn't failing. What was happening is the part num value itself was invalid, and that's what the function was reporting. I can't do anything with it. So what we came up with was a more graceful way of handling that particular type of error condition without changing how dbinfo itself works. So we didn't break all of your shell scripts and other functions or utilities that were using it. The result is this new environment parameter that hands down has to win the prize for the longest Informix parameter ever. dbinfo underscore dbspace underscore return underscore null underscore for underscore invalid underscore part num. Yay, development. So yes, it's a long one, but you only need to set it once if you need to set it at all. So the session or the variable can be set at a session level, at a client level, or you can set it at an instance level before starting the instance, and it will affect all connected sessions. The value for it is off. That's the default value, and as a result, you will get your normal dbinfo type output, or you can turn it on. And if there is an invalid part number or a null part number, you will simply get a null value back. It will not break. Now, if you pass a null part number to the function, you will get a -727 error. And that's SQL features. So now we get to the last section, which is on ER. And there's some really good stuff here in this section. So a significant amount of work went into improving the performance of ER, and it covers the whole gamut of ER: capture, queuing, transport, receive, applies. The vast majority of this functionality is behind the scenes. There isn't a magic parameter that you need to configure and all of a sudden you've hit Valhalla with 5x times performance. Everybody gets it. The thing that I need to caution you on is the bulk of these enhancements will only occur in clusters between XC6 nodes. If you are using an XC6 node and connecting to XC5 or an earlier fixpack, some of these enhancements will not be available to you. We will deal with this automatically. There's nothing you need to turn on or configure. It just happens behind the scenes. So how great were these improvements? Well, in a series of benchmarks using 80 million rows, we did a series of loads, and in earlier versions, it would take us about 2 hours. Now in XC6, it takes us about 8 minutes. So there's about a 15+% or 15+ times performance improvement, but we're only going to tell you to expect 5 to 10 times faster because there are other variables that could affect your throughput. Previously, we could sustain about 2,000 transactions per second, but now we're up to about 10,000 transactions per second. CDR sync is significantly faster. However, CDR check is still about the same because we have to check each row. Does it match what's over here? Yes or no? And that just takes time. And as always, with all of these estimated performance enhancements, your mileage may vary. So don't take me to court if you only get 4% or 4 times faster versus 5. So as I said, there's no magic tuning that you need to do. However, there are some significant changes that occurred in the transport layer. We are disabling the NIF mechanisms, and between XC6 nodes, we are now using the SMX protocol, the same protocol that we use in the HA cluster. Why did we use that? Number one, that protocol is parallelized where the NIF mechanism is not. So we're getting significantly better throughput between the nodes just from the parallelism that comes from SMX. In addition, the NIF send thread could be and often was blocked based on numerous network conditions that the SMX just rolls right over and keeps right on going. So as I said, there's nothing you need to do. This is just automatically enabled. If you were talking to an XC5 or earlier, we will use the legacy NIF protocols, but as long as it's XC6 or higher, it's just going to use SMX. If we're using SMX now, how do we tune SMX to use ER? Here are some tuning guidance for some of the different SMX protocol or some of the SMX configuration parameters. For numpipes, we recommend about 2 or more per target node, and you may need more depending on what your transaction volume is. What we have seen is that a total of 7 is usually a good place to start in total for the instance, and then just monitor your send queues or your receive queues and see if those are growing, and if they are, allocate more SMX numpipes. The ping interval, the SMX ping interval can be significantly reduced from what the default value is for the HA cluster. We don't need to have that level of insight into is the node there, is the node there, is the node there for failover. Set it at 30 seconds, and that's more than adequate. It will significantly decrease the amount of overhead on the transport layer. Ping retry, leave that at 6. It's just fine. If you want to use compression, you can use you should use SMX compress now as opposed to CDR NIF compress. And if you want encryption, we encourage you to use TLS rather than the encrypt SMX, but that obviously is up to you and whether or not you want to manage the keys that are involved with TLS. There have been some changes to the queuing and apply components. So the CDR QMEM parameter is configurable between 128 megabytes and 4 gigabytes, but we recommend you leave it between 256 and 1 gigabyte. This is one of those cases where if some is good, more is not necessarily better. This parameter is used to determine how much memory is used for the send and receive queues. And what we found, particularly in XC5 and earlier, is that if you increase the value, particularly above 128 megabytes, we actually saw a negative impact on performance. Under these new parameters, set it at somewhere between 256 and 1 gigabyte, and again, test and see what happens. The CDR eval threads, the guidance used to be CPU VPs plus 2. We're now recommending that you start with 7. Test, monitor, see what happens. What we're finding is that if you increase that number above 20, it will have a negative impact on performance. 7 just seems to be the sweet spot for this. So set it there, and unless there is something really bad, then change it. In the send queue mechanism, there has been a significant change here. Previously, the header information for a transaction was written into the queue header DB space, but we kind of deprecated that in 1210. And what we said is the header information will now be written into the same DB space where syscdr is created. The transaction data is still stored in a slob space that you identify with the queue data slob space. And when a transaction was flushed, we'd have to do IO to both of these spaces. In XC6 now, it is possible for the transaction header to also contain the replicated data itself. The caveat is that the replicated data has to be smaller than 26 kilobytes. If it is, the header has been expanded to include that data, and as a result, we only need to query the syscdr database, and we'll push not only the header, but the data at the same time. So if you have small transactions, you're going to see a significant reduction in I/O for ER. If your data is larger than 26 kilobytes, it still will be written into the QData SV space, and you won't get that performance improvement. But it's still going to be significantly faster because of the SMX protocol. On the apply side, it gets really exciting as well. Applies were always sequential in log sequence number order. It is now parallelized for changes within the same table, including out of sequence writes. So if you have a table and you have 4 different transactions that need to affect unique rows, so each of those 4 transactions is affecting 4 different rows, we will now apply all 4 of those changes in parallel at the same time. If a transaction has multiple updates within the table, we will apply the different portions of the updates within the table in parallel as well, so that things are occurring out of sequence. Now, some of you may be freaking out and saying, but wait a second, how do acknowledgements occur? How do we know things are being applied in order? There is a new hidden table that I just call the parallel apply table. That's not its real name, but just think of it as a parallel apply table. It is keeping track of what data is being written where within the table. As the data updates are occurring, think of this as a status table that's saying, okay, I've got part of this transaction over here and part of that transaction over there. And once a transaction is complete, then it sends an acknowledgement to the acknowledgement mechanism, which does send acknowledgements back in log sequence number order. So we can be doing these applies out of order. The parallel apply table will simply reply to the acknowledgement threads, hey, this one's complete, this one's complete, this one's complete. And when it can reply back in LSN order, then it starts pushing out all the updates to the senders. This mechanism has been tested extensively under failure conditions and just about everything else you can think of, and it does work, which is really, really nice. Now, there is a caveat to this. Well, it's really cool that we can do things in parallel and it's going to be significantly faster. If you have apply triggers on your table, you will start getting apply actions that may be out of sequence. No, not maybe, will be out of sequence, which may cause you problems. Now, there is a way that we can disable this. There is some voodoo that the technical support organization can sprinkle on your instance, but it will require you to contact them and ask specifically for it, and then they will dial into the instance and do what needs to be done to turn off the parallel apply so that you're back to the sequential apply. So that's the first part of what's new in ER. There is a new consistency check utility that's been added to XC6, and it compares the metadata about servers, REPLs, REPL sets, and templates between a reference or master node and one or more target nodes in your cluster. And it just makes sure, it just ensures that the object definitions are identical across all the nodes. It's called CDR check catalog. Again, you specify what the master node is, and you can specify what the target node is, or you can check all of the nodes in the cluster. There is a verbose and a non-verbose option. What's the difference between them? You just get more stuff out. The utility will return a 0 result code if everything is fine. If there are problems, then it will return one of the standard CDR utility numeric codes, and you can see them listed here that would indicate there's a problem with a REPL or a template or something like that. So that is now available to you. So let's use it. So this is some checks from my ER class. So I built my 3 or 4 node cluster that I use to teach ER with. And I said, okay, let's use instance 4 as my master and let's check instance 5. This is in non-verbose mode. And you can see that everything came back successfully. If you run it in verbose mode, what you get is a check and an identifier on each object. So is this template, is this REPL available, and is it configured? So that's what verbose mode gets you. Now, there are some caveats to this, some things that I found in the last day or so while I was testing this. There's some things that the utility does not capture. For example, I have a REPL called region move, and on a particular node, I disabled it, then ran the check. It didn't register that the REPL was disabled. It didn't register the fact that I was not replicating data to that node. If you disable a node, so I took instance 5 completely offline as far as ER is concerned, it didn't recognize that ER was disabled to that node. It just said, hey, everything's defined, so life is great. It also doesn't capture if a template has been defined in the cluster, but not realized in the cluster. So you can see I've got this update any template that I created using 3 tables. I defined that template on instance 4. It got pushed out to all the nodes, but I didn't realize the template for it. And so on instance 5, you can see that all the REPLs are inactive. So there are some things that this utility doesn't capture. Will they be added? I don't know. These are things that I've just found in the last 24 to 48 hours, and I need to get in touch with development and say, hey, what are we doing with that? So that's what that particular utility does. If you are using ER, there is a specific migration process that you must follow when moving to XC6. Just like on the HA cluster, we have to go through some conversion. There is some conversion required for ER. So it will require an outage. You will need to take each node down. What we recommend is that before you take the node down, we strongly recommend that you make sure all the queues are empty and that the log replay position is set at current. And you can use these commands to check what your queue links are and your replay position and everything else. And then you will stop ER on that node. You'll turn the node off. You'll upgrade the binary, make whatever on-config changes you want, restart the instance. Since CDR was turned off on the node, before you turned it off, when you restart the node, ER will not start automatically. You need to start it for the first time under XC6 with the CDR clean start command. What that's going to do is go in and rebuild the syscdr tables. It will drop some, it will recreate some. And since some of the tables that are being dropped contain transaction information, that's why it's critical that your queues be as empty as possible and that your replay position be as current as possible. So once you run the CDR clean start utility, then CDR will come up and it will be ready to use this new XC6 functionality. That is everything I have for this session. Like I said, part 2 is now on July 13th, so let's see if there's any questions. For CDR check catalog, no, I have not tested that on earlier versions. I doubt that it will, but that's just a guess on my part. And is a CDR sync catalog coming? I don't know. That would be an excellent request for enhancement that you could plug in. Thank you for coming. I hope this has been of value to you. There will be a replay posted within the next 2 days or so. It will be available in the IBM Informix community pages. I will include a PDF copy of this presentation as well as the audio video portion.